Welcome to the Beyond Tech podcast, a podcast designed for engineers. We aim to demystify technologies around safety and give you all the information that you need in order to make an informed decision when designing a safety system.
We cut through the fluff and we try and avoid those generic statements like robust and reliable. And we take a look at the technologies in the challenges of the real world rather than just looking at the data sheets that only references best case scenarios.
Each episode will take on one gas or flame detection technology and break it down, how it works, when and where to use it, potential drawbacks, and any maintenance requirements.
So underneath the umbrella of flame detection, we have the three technologies. We have UV-IR, triple IR, and visual flame detection. And there is no better guest to invite on the podcast than Lars Wulf, our PM for flame detection. Welcome, Lars.
Good morning. Many thanks.
So, a visual flame detector, how does that work?
And a bit different to the other two technologies, maybe you have seen.
Yeah.
We are using an optical camera.
Okay.
So we really see the fire itself. That's
Right.
completely different. We are not looking for high amount of CO2 emission.
Okay.
We're just looking on the fire itself and the characteristic of the fire.
Okay. So, I assume it can't detect invisible flames, for example?
For invisible
Hydrogen?
flame,
Yeah.
hydrogen
Yeah.
is not possible
Right.
because you could not see the fire itself.
Yeah.
So normally you look on the flame shape, you
Yeah.
look of the color of the flame, of course the flickering and the dynamic of the flame detection. So that will be seen and analyzed by the camera and would be analyzed pixel by pixel.
Okay.
And only if you have really these four different effects in the camera system, it's really a fire.
Okay.
Otherwise, it could be something different,
Yeah.
but you need, of course, the flame shape, the typical flame shape. You need
Yeah.
a color maybe of a typical burning substance
Right.
in the combination of the flickering. Then, of course, it would be detected as a fire.
Okay, so you need a carbon element in that flame to give you
Yes.
that colour, maybe the smoke as well.
Yes.
Okay, very good.
So this is detecting the same way that our eyes see.
You will see the same like our eyes, but to be fair, our eyes are not as good as a camera system. So we could see maybe a close fire really easy if we have good eyes, but we could also detect from high detection range with the camera system, and you could also see small fires from the distance.
Okay.
So it's really easy. You only need a few pixels that will be activated by the algorithm, and then you will see a detection of a flame.
Is there sort of a delay that the detector goes through? You know, if it sees these pixels and does it wait like a couple of seconds just to confirm that it is a flame and not just someone with a torch?
It's more milliseconds than
Oh,
seconds to
That
analyze
quick.
that. It depends how big the fire is, of course. If you're in a close distance and you have a big fire, then it's really
then
easy.
it's-
That's clear. And if you have a high detection range and at the end you have a small fire, then it will take a bit more
a little
time to be
longer.
fair. So, but the really advantage then, of course, is you could see the same like with our eyes. So you have a CCTV camera system in the combination of a flame detector.
Oh, so the detector can actually be used as a CCTV system as well?
Yes, correct. You will get two signals. Or to be fair, you get
Like two
three
feeds.
different
Oh.
signals, output signals. You get a 420 milliamp signal in the combination with hard. You get relay outputs and you get the video signal. So, and you could use all the different signals in combination if you wish, or you only use once of this.
Yeah.
It depends on the application.
Yeah.
So it's so if I'm visualizing, so it's a camera, right? So
Good pun.
Yeah, you're welcome. More to come. So it's so the field of view, I guess, would be like 16:9 ratio, would it, or
Yes.
like on a typical camera, or
Yes.
something?
Yeah,
So, and then what's the cone of? Or is it still a cone? Or
No, it's not a cone.
Right.
You could see really a whole area without any disadvantage to the edge of the camera system.
Okay.
You can see everything in the whole field of view of the camera.
Yeah, so
Okay.
there's no signal weakening
No,
towards the end.
no. Of course, if you go to the end of the field of view,
Yeah, if you drop off.
you drop off. Then of course you get problems. Or if you have a misalignment of the unit itself, then it could cause problems. But everything what is in the field of view would be analyzed by the camera system and could be detect the fire.
So why would you choose visual over the other technologies that we've discussed, the UVIR and the triple IR?
The main advantage is, of course, if you get in problems with high amount of CO2, then of course you always get a false alarm with a triple IR technology or with UVIR, because it will detect the high amount of CO2, and that would not be seen by a visual camera system because there's no fire.
Right.
Yeah.
Okay.
That's the main reason. And if you have application where you maybe a flare is burning, then you always get a high amount of CO2, and that will cause problems. But it will not cause problems for a visual flame detector. It would only get an alarm if you direct look on the flare itself, via the camera system. That's clear.
Right.
But if you look in maybe the safety area what you would like to cover, then there is no problem because the high emission of CO2 not activate the camera system.
Yeah. So what would you say are the key problems that the visual detector solves that the others don't? The CO2 or?
Yes, the CO2, also the high coverage. So you could cover a big distance and a big area with a visual flame detector compared to, as we explained that before, that we have a cone field of view for a radiation flame detectors like triple IR or UVIR. Then of course you have some disadvantage if you come to the edge of the cone or to the end of the detection range.
What is the detection range? Is it longer?
It is currently with the existing units, it's nearly the same like the triple IR unit. So it's also, like we discussed that before, around about 50 meters. But in the future with our new technology, we will switch over to an HD camera system in this year. We could triple the detection range that we have today.
Triple.
Okay. So there's more advances to come in this technology.
Yes, of course, more advantage then, of course, and also interesting for the customer because he don't need maybe 3 devices. He only needs 1 device to cover the same area. That's the strong advantage.
Okay. Do we see any misconceptions that pop up in specifications? You know, potentially people kind of just reusing technology that they've used in the past.
I think the main topic beside that is normally you use as what you know.
Yeah.
If you know triple IR technology and you're comfortable with that, and you know also maybe the disadvantage of the technology, then you normally could cover that in an application. But if you really struggle and you don't know that there is a different technology that could be used, and unless the situation that it is not possible to detect an unseen fire like hydrogen with a visual flame, but the rest hydrocarbon could be seen, all the different hydrocarbons could be detected, it could be a good choice in the application to use a visual flame detector because you will get the same output. If you only need 4 to 20 milliamp, you could also see that or get that from a visual flame detector. That's the same installation like we have in the past. It's just better for the operator to combine that with video management system because then you have really a strong advantage. You will see the fire itself. You could see where the fire is. That's different to the other flames. For the other flames, you only get the detection, but you don't know where the fire is.
There is a flame.
Yeah, there is a flame, but you have to go there to find out where is the flame. With the visual flame, you will see that.
Right. So you can look back at. So it saves memory, right, of an event, or
yes.
Yeah. So you can look back and pinpoint where that flame emanated from.
Correct.
Very good. Well, that seems like money well spent. I assume the technology is more advanced, so therefore it's a higher investment per device. But as we've covered already, or another pun, it covers a wider range of the plant, so you might have to have less devices.
Correct.
But also as another asset to pinpoint process problems, etc.
Yes.
Okay. We've looked at the environmental conditions. Is there anything else we need to look at when installing?
Yeah, like we have that for the other flame detectors. You have to be on the safe side if you have a free line of sight.
Right.
If you have something blocked the line of sight, it would not be seen by the camera. That's clear.
Yeah.
So
that's
if maybe something is in the line of sight, then it's difficult. Of course, we have to be careful with the situation if we are in a harsh environment. The same situation like for every flame. If something is on the lens, it could be cause problems. That's clear. That's the same for a camera system. If there is some rain on the lens, or there's oil or other things that could be blocked the camera system, or could be less performance then of the system.
But that's no different to the other technologies, right?
The same sort of maintenance.
Yeah, you still need them.
Not really. There could be a problem because it's a camera system, and if you have direct sunlight directly coming to the camera,
and a glare.
that could cause some problems.
Okay.
That brings us to the situation for all the performance of a camera system. What is the right algorithm? Find the right balance between fast response time and a reliable system.
Yeah,
so you have to tune the algorithm as best as it can, or balance out for the different application. So in our visual flame detectors, of course, there is a algorithm that could cover the direct sunlight and the flickering of the direct sunlight. But of course, that could cause some problems.
Okay.
And how long have these algorithms of visual flame detectors been getting fine-tuned for?
Our experience, it's over 20 years now, to be fair. So a lot of experience going in. And of course, if we do a performance approval on these detectors, it is always a mixture of detecting different substances with different sizes of fires and also different detection ranges in the combination of environmental problems like sunlight, like rain, like fog, like snow or ice on the lens. So to combine that, to test everything in the combination, and with this to have the best performance for the detector.
So you could really say they have seen it all.
Yes, they have seen it all.
Yeah.
Yes, correct.
So talking about seeing it all, what happens at night? Is it affected or
no? It's not affected the camera system. Yeah, it is a bit different, but it's part of the algorithm to analyze if we are in day and night. But it's not a problem at all.
And then you go back to sunlight. So I guess you need to take care of the equinox, right? So when the sun is high in the sky, sun is low in the sky. I guess.
Correct.
Some thought around
it's
that.
Also part of the installation process to be on a safe side.
Okay.
So if you could cover the unit, and we are talking about covering also for harsh conditions like the weather, it's the same situation for the sunlight. If you use a weather shield, then less sun will become to the lens of the unit itself.
Okay.
So to the camera. So that could also be a way how we will handle that. We discussed that also for the other technologies. Normally, we place the unit on a higher position and looking downwards.
Okay.
And due to this, we could also cover a bit more the situation that there is no direct sunlight on the unit.
Yeah.
And I guess puddles and things like that, is that just
What, like the sun hitting a puddle?
Yeah, like a reflection. Is
the reflection from the water could be also cause some problems. So if you are maybe on a ship and you look on the ship itself, but of course you will have a reflection from the sunlight from the water line. That could also be some problems. But normally, that I explained that before, the algorithm has been balanced out between the performance to detect the fire and to cover the environmental.
And are ships pretty common use cases for the visual flame detectors?
Yes.
Okay.
There are some typical use cases, maybe a ship or an FPSO that produced oil from the sea could be a solution. Also, an aircraft hangar where we have a lot of hot CO2 coming from the exhaust of the planes could be cause some problems, and due to this, it's better to use a visual flame. Also, if you would like to cover a bigger area, it's much easier because you have a big field of view during the camera.
Right. Excellent. Okay. And then the maintenance and the servicing, are we using the same tool as we've used for the other technologies? So it's again a flickering lamp.
Yes, we have the same tools that we use. We are using a flame simulator. Normally it's the same. Of course, the camera don't need really a calibration. But of course, it makes sense depends on the environment itself. But looking once or twice a year about the camera or the detector itself, if the lens is clean, there is nothing with the wiring or other things that has to be checked. And of course, using the flame simulator to activate the device and trying out if everything is correct. So the setup of the device, detection range, free line of sight would be tested by the test simulator or flame simulator.
Okay.
So you've got two. So it's a normal flame detector, but you could also take a signal out to a security system. Visual,
Yes, of course. You will get the video signal out, and you could also use that as a CCTV camera just to see the application itself.
Right.
Not seeing the flame, seeing the application.
Okay.
And you will have the second output of the detector. It could be maybe, for example, 4 to 20 milliamp for the safety system. So it will go to the fire and gas detection system. And due to this, you will really get the alarm to the system. And you use the CCTV camera to operate or to see what is in the area.
So it can sit on your sill loop as normal, but also give you that other
Correct.
signal out to it.
Correct.
Very good.
Nice.
So I think that covers everything. Is there anything else you want to cover, Lars?
No,
But
I think it's fine.
We'd like our viewer to take away some key points, right? So we split that up into 3 sort of questions. So when would we choose the visual flame detector over others?
If you would like to cover a big area, and the second part, if you are having maybe strong CO2 emissions in the application, then of course the visual flame would be the better choice compared to the traditional technologies.
And what's something that people often overlook?
To look on the installation itself, so that you have whole coverage of the line of sight, and to have maybe a clean lens and a clean environment.
And the final one is, what's the real world truth when it comes to maintenance?
Normally doing a test with a flame simulator, just to be on the safe side that everything is okay and fine, and of course checking the unit itself, looking at on the lens if everything is clean and there is no problem maybe with wiring or something like this.
And could you use the visual output to check the visibility of it, see how clean the lens is?
You've got that perk.
Yes, it could be an option,
Yeah.
but I think then of course you have to move the detector, and that's not a good choice. So if you would like to look on the other detectors to check if they are clean.
Sorry, I meant
through the video feed.
Yeah, look through the video feed, right?
Yes,
and
of course.
see that what you're seeing is clear. And
so, and
okay.
if there is a lot of moisture maybe in the front of the lens, then of course you would see, okay, it looks a bit blind, then I have to go to the camera and cleaning the
and it's
lens.
just a normal, like you would use for your glasses, is it?
Yes,
Or, like a
correct
isopropanol or something
Yes.
like that. Excellent. Thank you very much, Lars. That
thank
was
you.
really good.
Thank you.
So we would like to take an overall key takeaway for Flame. What would be that one piece of advice that you would say to summarize flame detection as a wider subject?
There is never the flame detector that could be used. It always is a choice of the environment.
Right.
So substance to detect, detection range, environmental conditions, and due to this, you have to choose the right detector.
Okay, so there's no perfect flame detector. There is a perfect one for a specific scenario.
There are 3 different perfect technologies
3 different
that could be
perfect.
used.
Okay, right.
To be fair, and it's always a choice. What is the setup of the customer, and what will be the right choice to use?
Yeah. So that's a wrap for another episode of Beyond Tech podcast. If you're working on a project and you need a deeper understanding of the technologies that you're looking to specify, then you can go to our website, Dräger.com/EPC, where we have a whole library of in-depth technology information in there.
And we hope you found this podcast useful or beneficial. As we said earlier, there is 3 episodes for flame detection, so make sure to check them all out. And that's it.
The next episode, we go on to another technology, but the rules are the same. No talk of product, no fluff, and we focus on real-world scenarios.
Yeah. Thank you.
Thank you.
Bye.
Thank you.